All right, ladies and gentlemen, this is what you should come up with for your table, for example, 1B. Now, you could use 1, you could use 3. Why did I choose 0, 2, and 8 as my p-values? They're pretty numbers, don't they? Because I have this square root. So, again, your parameters are just saying it has to be greater than or equal to 0. You don't have to go in sequential order necessarily. You can skip around. But again, I picked 0, 2, and 8 so that when I took the square root of them, it gave me some nice integers to plot. All right? But regardless, you should get, sorry, it got a little softened here. You end up with something that looks a lot more like a parabola. This looks pretty good. Here it is. This is better. That's a better representation of what we have. Why did I throw an arrow on the end? Infinity, exactly. It's t greater. It doesn't have a definite finish line. It doesn't have a stop. All right? So now let's take a look at how we can convert x equals the square root of 2t and y is equal to 4t into rectangular form. So to go into rectangular form, we're going to do exactly the same process like we did the previous example. You need to pick one of these equations, eeny, meeny, miny, mo, doesn't matter, and you want to solve one of these for t. Which one do you want to solve for t? Second one. So I know that t is going to be equal to y over 4. So again, using your substitution, we're going to take out t out of the other equation and replace it with y over 4. So x is equal to the square root of 2 times y over 4. Looking at the graph we got, this looks a lot like a parabola or possibly a line, half of a parabola or a line. So I know, regardless of which one it's going to be, I need to solve for y equals. Parabolas that open up or down in the form of y equals, lines are in the form of y equals. So now you want to take this equation and solve for y. So x is equal to simplify 2y over 4 to the square root of y over 2. How do you solve for y? Square both sides. So x squared is equal to y over 2. So what's y equal to? Y is equal to 2x squared. But now, remember, ladies and gentlemen, if you graph 2x squared in rectangular, you're going to get the whole u. Graphically, that's not what I have. So you need to include in this equation what the restriction on the domain would be in order to produce just this part of the graph. So what is the domain restriction going to have to be here? X is greater than or equal to 1. Without it, you do not have the graph that's represented. So if you need that domain restriction, make sure you include it. So any questions, ladies and gentlemen, on how you can graph an equation, parametrics, and then do the conversion? So now we're going to take some unique parametric equations, and that parametric equation involves sines and cosines. So x equals a cosine t, y equals a sine t. Quick review, ladies and gentlemen. Ladies and gentlemen, we've gone over, guys, shh, because I'll push back into sine t. Rectangular form of circles. Just to review what the standard form of circles are going to be. Remember, in rectangular, the standard form of a circle equation is x squared plus y squared is equal to r squared. That's where the center is at 0, 0, and the radius is r. You may also have a circle that does not have the center at the origin. So x minus h squared plus y minus k squared is equal to r squared. This is your standard form of a circle that has the center at hk, and then the radius is still the r. So we talked about the standard form of the equations in a circle. Something else to remember from Algebra 2 land, ellipses. What is an ellipse? It's the shape of a oval. It looks like an egg or an oval, exactly. So you need to remember what the standard form of your ellipse formulas are from Algebra 2. So the standard form is the center of the ellipse is 0, 0. So with your ellipse, if the standard form, if the center of your ellipse is at 0, 0, then the standard form will be x squared over a squared plus y squared over b squared equals 1, where a and b are constants. If the ellipse does not have a center at 0, 0, the numerators look a lot like the circle equations, the standard form. So it will look like this: x minus a squared over a squared plus y minus k squared over b squared is equal to 1. And the center would be at hk. When you see parametric equations where you have a sine in one and a cosine in the other, that's how you know you're going to have a circle or an ellipse. That's why I wanted to refresh your memory what these formulas look like. So the way you have, you get circles and ellipses in rectangular, you will see sines and cosines in these equations. Right? The way you convert an equation is into rectangular if it's a circle or an ellipse. Again, this is what the equation A will be some constant. So again, what you have to do, go back to your Pythagorean identity. The Pythagorean identity, remember, that we talked about with sine and cosine, is sine squared x plus cosine squared x is equal to 1. So the way you convert an equation from parametric into rectangular is you've got to take your equation and you're going to solve for sine and cosine. So x equals a cosine t. If I solve for cosine t is equal to x over a. If I solve for sine t is equal to y over a. So you take these two equations, your parametric equations, and you solve for sine and cosine. Then you're going to substitute into your Pythagorean identity. So take out sine, replace it with y over a. So I'll have y over a to the second power. Plus, take out cosine, replace it with x over a to the second power equals 1. If you have a circle, these two numbers are going to be the same. The denominators will be the same. If it is an ellipse, these two denominators will be different. So basically, when you are given the parametric equations, you can tell right away if it's a circle or an ellipse. If the coefficients are the same, you know you have a circle. If the coefficients are different, it's got to be an ellipse. So that's how you can tell the difference from the parametric equation. Okay? One thing that will be a little different than what we did in the previous two examples are the parameters. The parameters may look different because they're going to be in terms of radians or in terms of pi. So for example, if you want to graph or you are given a set of parameters and it produces a full circle or full ellipse, you still have to put the direction on it. If you have one complete revolution, remember, your parameters are going to be from 0 to pi. 2 pi. 0 less than or equal to t, less than 2 pi. That will produce the entire circle or ellipse. If you're only going to see half of the circle or half of the ellipse, the parameters could look a lot of different ways. So for example, if I see only this part of the circle or ellipse, what do you think my parameters would look like? T less than or equal to 3 pi over 2. So the top half would be from 0 to pi. So the bottom half would be from negative 2 pi to, would be pi to 2 pi. You may see parameters that look like this. I'm doing this again. 0 less than or equal to t less than 4 pi. It's hard to tell just given the graph that you have two revolutions. Typically what they'll do though, they'll double the amount of arrows that are on the circle in the two places. That's how you know it's more than one revolution. There's no way to tell from the graph whether it's a one revolution or two revolutions. Typically, you'll throw in more hours. So any questions on the resolution part for the comment? So let's take a look at the example here. We have x equals 2 cosine t, y equals 3 sine t. Is this going to be a circle or an ellipse? Ellipse. How do you know? Coefficients are different. Exactly. So I know it's going to be an ellipse. So first of all, they want me to find the rectangular equation of the curve. So step number 1. What you want to do, remember, is you're going to take your parametric equations and solve for sine and cosine. So I know that cosine of t is going to be equal to what? It's going to be equal to x over 2. Sine of t will be equal to y over 3. Now substitute into your Pythagorean identity. Sine squared t plus cosine squared t equals 1. So I'll take out sine, replace it with y over 3, and I'll square it. Take out cosine of t, replace it with x over 2. Equals 1. When I square my fraction, I'll end up with y squared over 9 plus x squared over 4 is equal to 1. Centers at 0, 0. Okay, are we good? So now we're going to graph by hand. Just like we did in the previous examples, you're going to make your t-chart. They're giving you the parameters from 0 to pi, so I know right away I'm only going to see half of this ellipse. Now, since you're graphing and plotting points, don't worry about using anything other than the quadrantals. You know it's a circle, you know it's ellipse. Because you know pi over 3, pi over 6, and pi over 4 is going to give you those ugly decimals anyway. So just worry about picking your quadrantal angles when you pick your t-values. So I'll choose 0, pi over 2, and pi. So x equals 2 cosine t, y equals 3 sine t. And that's how I can calculate the x and the y coordinates here. So just like I did, now you finish it for me. Fill out these points. So we have 2 times the cosine of 0. And what is the cosine of 0? 1. So my first x value will be 2. 3 times the sine of 0. Sine of 0 is 0. So my first point will be 2, 0. Next I have 2 times the cosine of pi over 2. And 3 times the sine of pi over 2. So what's the next point going to be? 0, 3. And then finally 2 times the cosine of pi. And 3 times the sine of pi over 2. The next point will be what? Negative 2, 0. You guys go ahead now and do the graph for me.